Algebra 1 students, welcome to section 9.4, factoring to solve quadratics. Some of you have been doing really well with factoring, some of you it's been more of a struggle. But if we can figure that out, we can all handle this. The big idea today is we're going to look at how we can use factoring followed by something called the zero product property to solve many quadratic equations. Alright, so the zero product property, it's a very useful mathematical property. You will see it in every class you take from here on out. And it's simple. It just says if A times B equals 0, then A has to be 0 or B has to be 0. 0 is unique. There's no other number that would work here. You can't have a 1 product property or a negative 17 product property. Only 0. 0 is the only number where when we multiply, one of those two numbers has to be 0 or perhaps both. So let's take a look. Let's use the zero product property to solve a couple of equations. Now, these are already factored for us, so these are nice. But essentially what we have is x minus 4 times x plus 5 equals 0. One of those two terms has to be 0. So we would say x minus 4 equals 0 or x plus 5 equals 0. That gives us two simple equations to solve. We can add 4 to each side here. We'd have x equals 4, or, and then over here, of course, you would subtract 5, so x would equal negative 5. That quadratic has two solutions. We've seen quadratics with two solutions. Remember, that means that the graph would actually have x-intercepts both at positive 4 and negative 5. As a matter of fact, just knowing that the first coefficient would be positive and knowing that I'm going through positive 4 and negative 5, I could get a decent idea of what this graph would look like. Of course, I should actually hit that point. We'll just make the point bigger so it connects. There we go. All right, let's take a look at another one. X times the quantity of 2x minus 3 equals 0. Again, I've been nice to you by having it in factored form. So we know that x is going to equal 0 or 2x minus 3 equals 0. Now x equals 0 is already taken care of. We just need to go ahead and solve this equation. So we'll add 3. So 2x would equal 3. Then we can, of course, divide by 2. And we would have x equal to 3 halves. Don't forget that we have that other answer up there of 0. Now sometimes we write it like I did on the first one, x equals 4 or x equals negative 5. You can also just separate answers with commas. All right, now the remainder of these questions, we're going to have to actually do a little more work on our own to set them up. We're going to have to factor. So we have different ways of factoring, and the first one I can see right away, the x squared plus 5x minus 14. I know I can put that into two groups. The only way I can get an x squared right here is if I have x times x. The fact that this symbol right there is negative tells me one of these has to be plus, one has to be minus. And 14, our options are 2 times 7 or 1 times 14. We need a difference of 5. That would be 2 and 7. And I see the middle term is positive, so I need the bigger of those two numbers to also be positive. So there it is, x plus 7 times x minus 2. Now this is where we started on problems 1 and 2. So we would know that x plus 7 would equal 0 or x minus 2 would equal 0. So our solutions would be either negative 7 or positive 2. Zero product property, very useful tool. All right, let's do the same thing on number 4. As a matter of fact, why don't you pause the video for a moment and work through number 4 on your own and then compare your answer to mine. All right, so you can see my work now. I've found that x has to be either negative 4 or negative 2. I've factored x squared plus 6x plus 8 to be x plus 4 times x plus 2. That's a pretty basic factoring problem. I'm quite certain all of you can handle it. All right, let's take a look at number 5. 2x squared equals 6x. Now there are a few ways we could approach this one, but here's what I'm going to suggest. Since the instructions ask us to factor, let's move everything to one side of the equation. So I'm going to do minus 6x equals 0. I've subtracted 6x from each side. Now, the factoring here, because I have just two terms, is GCF factoring. So what I can do is take out a 2x, and I would have x minus 3. So 2x times the quantity of x minus 3 equals 0. A lot of you right now can just jump straight to the answers. If 2x equals 0, then x would have to be 0. That's the only way that can happen. If x minus 3 equals 0, then x would have to be 3. Again, we're using the zero product property. All right, number 6. So far, this is the toughest one that we've had to factor, but I'm going to use the AC method, which will simplify things for us a little bit. AC here is 42. And I know some of you are noticing that it's negative, and you can address that the way you think is fitting. If you want to include the negative, totally fine. And I'm breaking down this number 42. There are a few options here, but I'm looking for two numbers that have a difference, of 1, and I see that right there with 6 and 7. So what I'm going to do is rewrite positive q as 3q squared plus 7q minus 6q minus 14 equals 0. Now remember, when we use that AC method, these two middle terms right here have to be exactly the same. So 7q minus 6q is 1q. So it matches. We're on track. All right, group factoring time. I'm going to go ahead and put that negative sign inside the, whoops, don't want the 0 in there. Put that negative sign inside the parentheses, but I have to remember it's really adding now in between. So here we go. First two, I'm going to factor out a q. That's going to give me 3q plus 7. 3 and 7 are both prime. I can't do anything else with those. The last two terms, I can factor out a 2, and I would have 3q plus 7. This is all still equal to 0. And to finish off our group factoring, this would be q minus 2 times 3q plus 7 equal to 0. It's time to use the zero product property. Either q minus 2 equals 0 or 3q plus 7 equals 0. So we would know from q minus 2 that if we add 2 to each side, q would have to equal 2. Over here we would have 3q equals negative 7, so then q would be negative 7/3. You'll probably notice we're getting two solutions pretty regularly as we solve by factoring. That's not unexpected, since we are dealing with quadratics. Typically a second degree function. We have three options, I guess, 0, 1, or 2. A lot of the ones we're solving, we're going to get 2. That's just the way it usually works. All right, we have 2 left. Number 7's, again, solved by factoring and the zero product property. Now, in section 3, we looked at a problem like this and approached it by solving with square roots. That would still work here, but I'm going to actually follow the instructions. Try that sometime. It's a good idea. And I'm going to factor. So I'm going to put everything on one side, equal to 0, and I see what I have right here is a difference of perfect squares. So I know this is 4w minus 5 times 4w plus 5, and that's equal to 0, of course. And now I can go straight to the zero product property. Here I would have w equals 5/4. Over here, I'd get 4w plus 5 equals 0. That would give me a negative 5 divided by 4. Now, if you want to just do this at once, you can have your answer look like this. W equals plus or minus 5/4. And if you want to write it that way, it's great. If you'd prefer to do w equals positive 5/4 or w equals negative 5/4, that's lovely as well. All right, last one. We have 4 terms, a third degree first term. So I'm going to try group factoring here and see if this will work. Put a plus sign in between, since I've kept the negative inside the second grouping. So we will factor out an x squared. We'll have x squared times x minus 3 plus, And looking at this, I actually need to factor out a negative 4, so I'm just going to make that minus 4 times x minus 3 equals 0. So here we go. We'll have x squared minus 4 times x minus 3 equals 0. Don't stop there, though, because if you look at this, x squared minus 4, that's still factorable. I'm sure you guys all caught that. I didn't have to make a big deal out of it, but you keep factoring as long as you can. If it's factorable, do it. All right, so here we go. Now I've got 3 terms being multiplied equal to 0. This is kind of an interesting idea, but the zero product property still applies. We looked at it as if A times B equals 0, but you could definitely add other terms. A times B times C equals 0. Then A, B, or C, one of those at least, has to be 0. So our solutions would be 2, -2, and 3. And I'm just going to write the answers like that. All right, Algebra 1 students, some of you are realizing if you're good at factoring, these are easy problems. If you're not, it's going to take more practice. But whatever you do, don't stop believing, and let's get this figured out. You guys have a great day.